Hi, in this video I'm going to prove these two identities. Let me take the first one. We have 1 over cos theta plus tan theta identical to cos theta over 1 minus sin theta. So how we can prove this identity? We can take one side of the identity. Let me take LHS, left hand side. You can write it down. We have 1 over cos theta plus tan theta. So we need to simplify this to get this single fraction here on the right hand side. So if you look at the right hand side, always we need to do that. We can see cos theta and sin theta there. So what I'm going to do, left hand side, we have tan theta. So I'm going to write tan theta in terms of sin theta and cos theta, because we can write tan theta equal to sin theta over cos theta. So the first thing, I'm going to write that 1 over cos theta plus tan theta I write as sin theta over cos theta. Now we can see that we're going to add these two fractions together to get this single fraction. So we can see already cos theta is the common denominator. So we can take cos theta as the denominator, and we can add numerators together. You would get 1 plus sin theta over cos theta, right? Now look at this side again, how we can get this result. But we have just this now. We need to think about it. What I'm going to do, I'm thinking of getting 1 minus sin theta in the denominator. So we do this kind of techniques when we prove trigonometric identities. So what I'm going to do, I'm going to multiply denominator by 1 minus sin theta, right? So if I multiply denominator by 1 minus sin theta, we have to do the same thing to the numerator. Now you can see what's going to happen here, right? When you multiply 1 plus sin theta by 1 minus sin theta, here we have now difference of squares. Therefore, we can write numerator as 1 square, which is 1 minus sin square theta. In the denominator, I'm not going to expand this because I need 1 minus sin theta in the denominator, right? So I keep this cos theta times 1 minus sin theta, right? We know that 1 minus sin square theta equal to cos square theta, because we know this identity for any theta, sin square theta plus cos square theta equal to 1. So if you take this one to the other side, you have cos square theta equal to 1 minus sin square theta, because in the numerator we have cos theta. So I want to get that there. So I'm going to replace this 1 minus sin square theta as cos square theta, right? So let's do that. In the denominator, we have cos theta times 1 minus sin theta, right? So now you can see actually what is happening here. We can see that 1 cos theta you can cancel out, okay, because cos theta is common factor to the numerator and denominator. Therefore, I'm going to divide top and bottom by cos theta, right? So that gives us cos theta over 1 minus sin theta. So that is the result we have here. So we prove the identity. Okay, let me take question number 2. We have 1 over sin theta minus sin theta identical to cos theta over tan theta. Let's see how we can prove this. Again, I'm going to take LHS of this identity. right? So again, we need to put this to fraction as single fraction, because sine theta we can write as sine theta over 1 if you want. So we have to simplify these fractions to get this single fraction. Okay, so to simplify this, I need common denominator. We can make sine theta as common denominator. To get that, I times the denominator in this fraction by sine theta. Therefore, we need to do the same thing to the numerator. Now, we have sine theta as common denominator. We can simplify numerator. We have 1 minus sine square theta here. Right? So what we can write in the numerator, we see in this here, right? 1 minus sine square theta, we can replace as cos square theta. So I'm going to do that. So we have cos square theta over sine theta, right? Now, look at this expression. We need to get this. So what we have to do always, we need to rearrange this result to get this result on the right hand side in the identity, right? So I can see that cos theta in the numerator. So we have cos square theta at the moment, right? I'm thinking at the moment how we can get cos theta, just cos theta in the numerator. So what I can do, I can split this cos square theta as cos theta times cos theta, right? And we have sine theta in the denominator. So I write it here. I isolate cos theta, right? So I have cos theta times cos theta over sine theta. If you look at this here, this fraction, we know that tan theta equal to sine theta over cos theta, right? But what we have here, cos theta over sine theta. So to get that, I need to flip this fraction over. So I can, if I flip this fraction over, I need to even flip this fraction over. So I can say that cos theta over sine theta as 1 over tan theta, right? 1 over tan theta. So now I'm going to write that result here. We have cos theta times 1 over tan theta. So it is actually same as cos theta over tan theta. Now you can see that we have proved the result. We have cos theta over tan theta. That is what we need to get here on the right hand side. Okay.